Hello, ladies and gentlemen. My name is Aleksey Maksimov. I work at Samara National Research University, and today I'll be talking about optimal fusing of video sequence images. I'll be considering the image fusing in the context of multi-image superresolution, which is the formation of a high-resolution image based on a set of low-quality ones. It is actively developing area of research. Super-resolution algorithms are effectively used in various application fields, such as medicine, forensics, and many others. The proposed method is based on a weighted summation of frame sequence pixels. The weights are calculated in an optimal way. I'll begin with a quick overview of the basis of the proposed research, the optimal summation of unequal accuracy measurements. Then I'll present the proposed optimal image fusion algorithm. After, the experimental results will be shown, and I will finish with discussion and future work. And now let us turn to the optimal summation of unequal accuracy measurements. Let there be measurements which are presented with a different accuracy. Our task here is to construct an unbiased estimation of our value and to minimize the mean square error. For long story short, after differentiation we will have the expression which you can see on the right. As you may notice, the more interpolation error variance is, the less the weight of the value is. Of course, the derived expressions are not brand new, they are well known. However, we have found any application of this theory to the image fusion task. So that completes my overview of the optimal summation of unequal accuracy measurements. And now let us turn to the proposed algorithm. As you can see, it consists of 4 steps: the upsampling, additional channel calculation, frame registration, and weighted summation. The additional channel consists of interpolation error variances of frame pixels. The weighted summation is performed according to the derived optimal expression, which you can see on the bottom of the slide. I should mention that in this work the choice of the registration method was not in the scope of our research, so the popular and well-known solution was used. I suppose the algorithm is better to present by a block diagram, which you can see on this slide. Here you can see how the frame of observed video is altered during the processing. First, it is upsampled to the desired size, then the interpolation errors are calculated as an additional channel. After, the frames are registered, and finally the weighted summation is applied to the registered frame set, and we obtain the results of the proposed method. And now let us turn to the results of experimental research. The research was held on a grayscale video dataset. Videos were shot via a statically mounted camera. After that, the frames were downsampled and used to restore the first frame of the test video. Videos depict a calibrating board which undergoes some moderate movement. As you can see, some shifts and small angle rotations. As you can see, here on the slide, the paragon image is presented of the results of the proposed method, and at the bottom of the slide you can see some test video sequences. On this slide, the dependence of mean squared error on the number of test frames used to reconstruct the initial image is shown. As you can see, the use of the proposed weighted algorithm resulted in a significantly less error. Now let us turn to the discussion and future work. The aim of this article was to present the conception of the method. Obviously, additional research is required to enhance the proposed algorithm. As you may have noticed, the proposed method is heavily dependent on a choice of the registration algorithm. So the additional research is required to find out which image registration method fits the proposed algorithm the best way. After the choice is made, the comparative study on image fusion method is required to determine the quality of the proposed method. And the results of these experiments will be used in the development of a new superresolution method. So we have reached the end of the video. If you have any questions, feel free to leave them in the comment section. Thank you for your attention.